Let's take a look at the project browser organization from an electrical perspective. If you open the project, it may be set to another discipline. To set it to electrical, simply click Views in the project browser, and in the Type selector, select Discipline-Electrical. Now the project browser is filtered for electrical views. If we expand the Views section, we'll see there's a construction document section with demolition plans, electrical site plans, electrical power and systems. Lighting, power and systems. Under lighting, power and systems, we'll have floors 1 through 8 plus a basement level. We have a section for ceiling plans. This can be expanded for additional levels. You can see it has levels 1 and 2. In addition to construction documents, we have a coordination category, project setup category that allows you to manage the scope boxes for the project, and we also have a working category. The working category would be views without all the notes and annotations that you would normally find in the construction documents section, where those views actually go on the sheets. If we expand the power category, we can see the same levels 1 through 8 plus the basement. If we open up level 1, we can see that the electrical fixtures and equipment are color coded by view filters, which are controlled by the view template. You can see this view is controlled by E_power working. Notice the filters tell us whether the item is circuited, or if it's not on a panel but circuited, or if it's not on a panel and not circuited. This can also be seen in the lighting plans. So here are 3 can lights that have that same scenario. In addition to the views, there are also several schedules available for electrical use. These all have a E_ prefix. The mechanical and plumbing have M_ and P_. And then there are some keynote schedules and general note schedules that are grouped separately. Any panel schedules will show up in the panel schedule section. And finally, the sheets. All of the electrical sheets have an E prefix, and there's a series of common sheets that are used on a project, and these can be added to or taken away from depending on project needs. That concludes this introduction to the project browser from an electrical perspective. Let's take a look at the receptacle families. First, we'll go to the System tab. And by the way, the System tab, if you hold the Control key, can be repositioned to be the first tab if desired. It's also possible to turn off the Architecture tab and the Structural tab in Options if desired. On the System tab, we'll select the Device command, and then in the Type selector, we'll narrow down the list to search just for receptacles. So we can see the various receptacle families that come with the package. We'll focus on the receptacle duplex wall family. Notice the various types. So you can duplicate these if needed, or delete ones that aren't required for a project. If we pick 48-inch above finished floor, we can place that on the wall. We'll just place a few options here so that we can see what they look like. 84-inch ground fault interrupt. You'll notice the labels are showing up. In a later video we'll show how to adjust the labels. 84-inch isolated ground, emergency, GFI, isolated ground, standard height of 18 inches above the floor, and then standard. If we want to take a look at these to make sure that they are positioned properly from the floor, we can create a section. If this is just a temporary section, we'd want to use the electrical working section. You'll notice that this section it's clear that this section will not appear in this view because right now we are in the construction documents view. So if we're going to create a temporary section, we should switch to the working view. We'll go to the power working -01. Notice all of these receptacles are red, indicating in this view that they are neither circuited nor connected to a panel. So now if I select the section command, electrical section working, I can place a temporary section. I'll pull the depth of view back so that we only see up to this wall, and then we'll switch to this view. Now we can see the various receptacles that we just placed on this wall. One last thing that's more graphical rather than engineering related that we'll look at for a moment is if we select a receptacle, we can uncheck vertical, which causes the receptacle to rotate 90 degrees and be positioned horizontally. This is helpful if it needs to be placed in trim or you're representing an existing condition. Let's take a look at how the receptacle families are able to calculate electrical loads. If we select one of these receptacles, we notice in the properties there are several input options. So if we happen to know that the real power is 162 watts, we can enter that. And we'll notice down in the electrical loads, that the apparent load is 180 volt amps, the real power 162 watts, and the full load amps is 1.35. If we set that to 0 and change the apparent load, perhaps that's the input value that we are given, we can see that we have similar results. 180 volt amps for apparent load, 162 watts for real power. If we have full load amps, we could type in 1.5 and again see that we have 180 volt amps for apparent load, 162 watts for real power. If this happens to be a motor and we want to enter a horsepower load, we can type that up here in the motor power input. You can see the unit is in horsepower. We could do equal 1/3, or we could type 0.33. Notice the apparent load, real power, and the motor power are all showing up. And then there's also another value here called motor power NEC lookup. So this is the value that's being sent to the lookup table to get these other values in return. Also, it should be pointed out if we expand the text section that several families in the productivity pack have a message center. And we'll notice that because we're entering a horsepower motor load, it's telling us that the FLA value is coming from the NEC lookup table that's associated with this family. This video will show several ways in which the receptacle families can be manipulated to achieve various graphic results within the documentation. On the screen here we have a 3D view on the right, a plan view in the upper left, and an elevation view in the lower left. The first challenge that we'll look at is when a receptacle is aligned with a wall switch. In plan view it creates a graphical situation where the symbols are on top of each other and difficult to read. To solve this problem, the package has the ability to offset the symbol from the wall. So traditionally, if you were to just type in an offset value using the built-in offset command, it looks correct in plan. We can see the wall switch symbol is still against the wall and the receptacle symbol is away from the wall. However, that also moved the 3D geometry, as we can see in the 3D view. So to overcome this problem, we have another parameter called type offset here. So basically that means whatever you've typed in the offset parameter, type that same value in this secondary parameter. And basically what that does is it repositions the 3D geometry back into its original position, leaving the symbol and its connector out away from the wall. So if you're showing wiring, you can show your wire going to the symbol. So it still looks correct in elevation, in 3D, but in plan view, we have an opportunity to offset the symbol from the wall. The same would be true with the switch family. Another problem we might run into is when we have two receptacles close to each other. We can see in plan here that the symbols overlap and don't really look all that great. So when we select the family, we'll notice one of the parameters near the bottom of the list is offset along the wall, and this is talking about the symbol. So if I type 9 foot, we're basically just adding or subtracting from that default 10-foot value. So we can see the symbol moved in plan, but it's still in the correct location in elevation and the 3D view, and therefore would be in the correct location in the architect's interior elevations when this MEP model is linked into their environment. The last thing that we'll look at is how we can control the labels that are built into the receptacle family. So these are being controlled by the type, so GFI 84 inch. Oftentimes this label is not exactly where you want it to be. So some of the options to control this are we select the family, and then in the properties we see there's an option to make the text either vertical or not vertical. So that positions the text so that it's readable. If we select this label again, we have some grips here that we can actually use to reposition the label wherever we want it. There's a grip here that's a little trickier to grab because this is also the same location for the family grip. So we want to press tab one time and then drag it. And so with these two grips and the text vertical parameter, we can position that label wherever we want and not have to rely on using a separate tag. Let's look at how we can set up the utility transformer within the electrical and mechanical productivity pack. We're going to be working in the context of the sample project, so you can open this and select things and see how they're set up and kind of reverse engineer, if you will. So we have the transformer family, which represents the geometry that can be placed within a Revit project. However, because this cannot be shown as a panel schedule, we have to put this separate family We call it a bus connection. It's a piece of electrical equipment. So if we go to the Systems tab, Electrical Equipment, and then place the bus connection family, this is a face-based family and it always defaults to place on vertical face. So we're going to switch this to place on face. I'll just set this off to the side here temporarily. So it's hosted on the geometry, but it's not really part of the geometry. We'll notice when this is selected, we have the opportunity to create a panel schedule, which we'll talk more about in just a minute. Once the bus connection is placed, we'll want to set the voltage. So voltage nominal is the parameter that's used throughout the package, because the voltage parameter that comes hardwired in Revit is only a text parameter. We'll also want to set the distribution system on the options bar. We'll confirm the number of poles and then give this panel a name. Once we've done that, we can go to the ribbon and select Create Panel Schedule, choose Template, and then we'd want to pick this one called Electrical Load Estimate. Once you've done that, you have the utility transformer set up. I'll just delete that bus connection. We'll select the one that's previously placed, and we can see that the panel schedule has already been created. I'll click on Edit Panel Schedule, and this shows us all the load classifications that exist within this building and the total load for the building. This assumes that either the heating load or the AC load has been zeroed out, whichever is smaller. Revit does not have the ability to use one or the other. So that's a quick look at placing the utility transformer within the package. Let's take a look at how we'll handle the distribution equipment or switchgear within the context of the mechanical electrical productivity pack. Please take a look at the previous video on the utility transformer for additional pertinent information. So we'll be using the sample project as the basis for this demonstration. If we select a few items here and use Revit's selection box command, we can see a nice 3D view of what we'll be talking about. So we have the distribution equipment. If we select this main section family, we'll notice that we can override the clearance above the piece of equipment. So if we wanted to have just 2 feet clear maintained, we could type in that manual override and we see that happens in the 3D geometry. You can see we have 3 separate families to be able to properly represent what we need for this particular sample project. There's the bus connection family, the main section, and the distribution section. And of course you could have multiple distribution sections such as SW, BD, D2, D3. So in this case we have one distribution section. Per the user guide, you'll select each of these and enter the appropriate information such as distribution system, number of poles, nominal voltage. The other thing that needs to be done is the panel schedule is created for each one of these. So I'll just copy these off to the side. So when we select the bus connection, when we go to create a panel schedule, we would select the panel schedule called switchboard footer or distribution footer, depending on what type of equipment you're working with. Similarly, for the main section, the template that you would choose is either switchboard main or distribution main. And then for the distribution sections, the panel schedule template that you would select is switchboard distribution. We'll delete those, and then basically what you do is you take those 3 panel schedules, which are also appearing in the project browser under the panel schedule section. So main switchboard, distribution section 1, and then the main switchboard summary, which is based on the bus connection family. Those three panel schedules are composed together on a sheet to appear as one schedule. And you can see there are indeed three separate schedules, but together convey the information that we would want in the construction documents for this particular switchboard. Of course, as the distribution section grows, or if multiple distribution sections are used, those would have to be placed appropriately, and the load summary section may have to be manually moved down as this section grows or additional sections are added. This video will take a look at the high voltage panel boards in the Mechanical Electrical Productivity Pack. If we select the electrical equipment command and then in the type selector search for panel, we can see first of all the panel families, both lower voltage and higher voltage, that come with the package. You can see there are quite a few families and each containing several types. If we further refine this search by typing in 480 volt, we can see the number of higher voltage panels. So if we select one of these panels, and we'll just place it on the exterior of the building, this happens to be a recessed family. You can see the panel box is filled in black. There's a clearance space. If we select this panel, you can see that in the properties, based on the NEC table referenced here, we can select condition 1, 2, and 3 for the clear floor space, and then also an option to turn off the hatching, an option to make the floor hatch visible or not. So if we turn off the solid hatch, we can see the panel itself is no longer solid filled. If we turn off the clear floor space visible, that particular checkbox is related to something that might show up in the construction documents. The clearance object that's still showing up here, which is related to design and clash detection, that can be controlled in the visibility and graphics overrides, and that's consolidated under generic models. So if we turn off clearance under generic models, that'll turn off clearances for all the mechanical, electrical, and plumbing items. You can see here we'd have to do that in a view template if we wanted to turn that off. We also have the ability to offset the clearance. So the clearances, if there's two panels close to each other, we can adjust those so that they don't overlap, or so that they do overlap, depending on whatever the condition is. Once the panel's placed, we would set the distribution system, number of poles, and nominal voltage if they're not already set correctly, and then we can create a panel schedule for that particular panel. The user guide and the electrical title sheet suggests a naming convention for panels. If you choose to use something different, you'll want to edit that title sheet. In this video, we'll look at the lower voltage panel boards that come with the Mechanical Electrical Productivity Pack. These are panels that would require a transformer to hook to a higher voltage panel, such as this panel. We can see in the type selector, it's a 208 volt main lug only lighting and appliance panel board, surface mounted, 225 amp single phase. So if we select the electrical equipment command, and then in the type selector, if we search for the 208 volt panels, we'll place that same panel. So a surface mounted 208 volt main lug only, 225 amp single phase. We'll select that. It has a default elevation 4 foot to the center of the panel, and then we'll place that on this exterior wall just as an example in the sample project. When we select this panel board, there are several graphical options for clear space and whether the solid hat shows up or offsetting the clear space. This was covered in a previous video for the high voltage panel boards. Please refer to that if you need more information. Once we have this instance placed and selected, on the options bar we can select the distribution system. We can also give this panel board a name. So per the naming convention suggested in the user guide and on the title sheet, we'll just give it a name. We can then tag it, reposition that tag if needed. We can then create a panel schedule, and we have the option of creating a regular panel schedule, or if it's a single phase panel, we can use this option so that the shading and the number of columns show up correctly. To account for the transformer, we'll select one here just to see the type that's used. We'll right click and select Create Similar. When we select a transformer, we want to make sure we set the distribution system and the secondary distribution system. We'll also give this a name. We can do that either in the properties, or we can tag it and then select the family. Let me get this tag out of here a little bit so that we can select it easier. So we select the family, and then we select the tag, and T for transformer, and then the panel that it serves will be the name that we enter. And then when we take this panel that we just create a power system, we can then assign it to that transformer that we just created. And then of course the transformer can have a power system created and then connect to an upstream high voltage panel or distribution system. So that's a quick look at the lower voltage panels and transformers within the context of the mechanical and electrical productivity pack. Let's take a look at transformer schedules and how many elements in the package are tracked in terms of their location within the project. First, we'll pick up where we left off in a previous video on lower voltage panel boards and placing transformers. So we'll notice this transformer for panel 108 that's outside the building. If we go to the transformer schedule that's predefined within the package, we'll right click on schedules and select search. And this is just a quick way to find a schedule. So I'm going to open up that transformer schedule, and we'll notice all the transformers in the project are showing up here, including this one that was just placed as part of this video series ending in 108. We'll notice the location is blank. Revit has the ability to track what room an element is in within the project. For example, if this transformer is moved within the building, we can see it's now within this space called Spawn's Alley. If we go back to the transformer schedule, we'll notice that it's being filled out properly. So this is great when a piece of equipment is within a space or a room. However, if it's outside the building, as shown in this example, or perhaps on the roof, it would be nice to have the ability to override the automatic setting that Revit provides so that we could type in something like roof or outside. And so in the productivity pack, we've created that opportunity to use the override that's provided. We have to check this option, use space identity overrides. And then in that case we can enter a name and or number override. So in this case I'll just type outside, and so that we can see that we could also enter a number if we wanted to, I'll just type 000 for the number. Now when we go back to the transformer schedule, we can see our override is showing up outside 000. So if this were moved back inside, it would still use our override. You have to select the override option for that to actually work. Or you have to turn it off basically to get it to look at the Revit room that it might be contained in. This is also helpful if you want to override an element for the room it serves, perhaps, rather than the room it happens to be in. And then looking at the transformer schedule one more time, you can see the other values in addition to the name are coming from the properties associated with that particular family. Some of them are fixed and can't be changed, and some of them, like mounting style, is a manual entry, and we have the opportunity to enter notes. And when there are notes, we have a special way in which schedule notes are managed throughout the productivity pack. If we go to the sheet that contains the panel schedule, those will be found on sheet E8.03. We zoom in, we can see the transformer schedule, and there's a group that's placed manually on the sheet, and as you can see it needs to be repositioned as the schedule grows, but this allows us to manage notes below the schedule, and that's used throughout the productivity pack. So if we needed to add a note number 2, we'd select this footer group, select edit group, edit the group, and then finish. And that's it. This video will provide an overview of the schedules in the Mechanical Electrical Productivity Pack. First of all, we'll look at several coordination schedules. All of the electrical schedules have a E underscore as a prefix to group them together. We'll notice the coordination schedules are meant for internal design team use and not necessarily intended to be placed on sheets. One of the example schedules here is the cost estimating schedule. All of the families have a number of cost estimating parameters associated with them, and there's a cost estimating title parameter which groups specific families together, such as lighting fixtures or receptacles, and then those groups are subtotaled. We have the ability to enter labor rate and material rate and tax rate and things like that to begin to do some estimating. We could also manage soft costs by using secondary design options so that they only show up in the schedule and not in the project, by placing dummy elements basically that are used for tracking soft costs. We also have some load study schedules, so the light fixture electrical loads by room. We have the space schedule, electrical circuit schedule, we also have the circuit schedule analysis schedule. This basically shows the loads for the different panels in the project, and it has the power triangle. 2 of those are provided by Revit, and then we added a parameter with the formula to calculate the reactive load, which can be useful information. There's standard schedules based on elements in the project, like fire alarm device and fire alarm zones. the transformer schedule, which was looked at a little bit more in depth in a previous video where we talked about how the location can be overridden if needed. And then there's also the lighting fixture schedule. Most of the information that you see here is automatically populated from the content. And then finally, we'll take a look at the motor list schedule. There's two of them. The first one is based on mechanical equipment and only represents families that are in the mechanical equipment category. So this is something that the mechanical group would use to define equipment by checking this box, include a motor list that needs to be circuited, and then there's all kinds of parameters to track the cut sheet and QA/QC. We can see information about if there's multiple motors. All of the blue values are opportunities for engineering judgment for electrical to override information that mechanical has entered. We get down to the end, it calculates the multiple motors and summarizes in this mechanical equipment area. So we can see the real power input, which is the override in the blue, and then the calculated FLA and a FLA input so that we can override. And then as we continue down, there's circuit information. So this tells us what panel, what circuit, and then the apparent load, number of poles, motor, or the load classification. So this gives electrical the opportunity to verify everything in one spot and provide overrides if needed. The next schedule is a multi-category schedule. This is also going to include things that are not necessarily mechanical equipment, such as overhead doors, motors, and door actuators, and various things like that that also need to show up in this schedule. The only difference is this schedule does not allow the panel or the circuit number to show up over here in the circuit information. And this one has not been color coded yet as when this video was created, like the previous one was. Schedules are being placed on sheets, and a lot of schedules have footer notes, and those are all being controlled by groups that are manually placed on sheets. We'll see there's several schedules on the sheet and some of them have this footer group associated with them. And one of the challenges with this solution is that as the schedule grows, as you can see here, the footer group needs to be manually moved. If we need to add or edit the footer information, we just open the sheet, select this footer group, and then on the ribbon select edit group, and then we can edit this information. That's a quick look at the schedules and the schedule footers in the productivity pack. Let's take a look at how the fire alarm system is handled in the productivity pack. First, it should be pointed out that the fire alarm families have connectors in them that are not associated with the fire alarm system. Rather, they're assigned to be an electrical power system, and that's so that even though the voltages are low voltages, they can still be summed up on the fire alarm panel, which on a large project can result in a fairly substantial load. So to see the inner workings of this, we'll go to the MEP settings on the Manage tab, and then go to Electrical Settings, and then in the distribution section we can see that there are several lower voltage systems. So for example, 24 volt fire alarm system. This is the distribution system that the fire alarm panel would be assigned to, which would allow the fire alarm content to connect to that panel. You'll see there's a few other low voltage systems here, including avionics, telecommunications, grounding, television, 28 volt DC. So we'll cancel that. If we select this fire alarm panel, you can see on the options bar it's been assigned to the 24 volt fire alarm distribution system. Again, if the connector in the Revit family for a fire alarm device was set to fire alarm, we'll go to Edit Family, we'll select this connector, and we'll notice the type for this connector is power, not fire alarm. If it's set to fire alarm, it can't be associated with the distribution system, and we can't create a panel schedule. So when we select this fire alarm family, you can see there are a number of fire alarm families available, and some of those families have multiple types. And for, depending on the particular instance selected, this is a fire alarm strobe. So this has different candela options. We can have the strobe be on the right or the left, and then we can also turn the coverage graphic on. So depending on the candela setting, we can see how big of an area that has the potential of serving. So that's a quick look at the fire alarm system. Fairly straightforward, with the exception of the electrical connector in the family is set to power rather than fire alarm, and then that allows us to have fire alarm panel board schedules that we can calculate the loads on. In this video, we'll take a look at the lighting fixture families that come with the productivity pack. So in the sample project, we can see several light fixtures have been placed. If we select one of these light fixtures, we can see we have a few graphic options to control whether it's part of the life safety system or if it's part of a critical system. There's different fill patterns that appear, so those can be turned on and off. We also have the existing phase symbol. Families do not have the ability to track phasing within the family editor, so there's this opportunity to enter an existing phase symbol that you can see shows up in the type tag. So this particular family does not have anything entered for the existing phase. So if I were to enter that here, you can see it automatically shows up as part of the type, the identity type tag. And by the way, you'll notice that if we go to type properties, we don't use the type mark parameter. This parameter type mark is not available in the family editor. We have pre-populated all the lighting content with a type mark so that you can use that as a standard if you choose in your firm. And in order to do that, we have to make our own type mark. So it's called identity type mark, and you'll occasionally also see the instance parameter equivalent identity mark. All of the light fixture content has information pre-populated, such as ballast type, lamp information, and power load. So if you want to have different manufacturers, for example, some of them have 3 manufacturer equivalents listed, you can go through the content and adjust that if needed. If we take a look at what we're seeing here in 3D for a minute, I'll select all those light fixtures and then on the Modify tab, use the Revit command selection box. This brings us to a 3D view with a section box applied to encompass the area that we had selected when we picked the selection box command. And I'd like to point out that a lot of the light fixture families have a clearance object above the light fixture to allow for maintenance and installation. This will be used in clash detection. If you want to turn that off in a view, you go into the visibility and graphics overrides, and then all of the clearance objects for mechanical and electrical have been consolidated to this generic models category and a subcategory called clearance. So that one checkbox you can see turned off the clearance for the VAV box and for the light fixtures. It still exists in the project, it will show up in other views, and it will also work in clash detection. You can see this particular view happens to be set to fine level of detail, which makes the light switches and the receptacles look more realistic, which the architects like for 3D visualization and virtual reality. Going back to the plan for just a minute, we'll notice back to the tagging of light fixtures. One light fixture will often have 2 or more tags associated with it. This particular tag is called E-tag-lighting fixture standard. So there are a number of options to show the circuit and the switch ID. If we look at this particular room that has a switch ID system set up, the circuit tag itself will automatically show the switch identification system if one exists. So you can see in this adjacent room it's the same light fixture, but because the switching system hasn't been defined, it just doesn't show up. But as soon as it were added to this room, it would add the switch system. We also have several families for occupancy sensors and power packs, and all of that can be placed and tagged and quantified within the productivity pack. If I select a light fixture family, you can see there are a number of switches available. So I'll just do a quick search here for switch. Some of these are wall-based, some are ceiling hosted. So that's a quick look at the lighting fixture content in the productivity pack.